We good? All right. Cool. So thank you everyone for coming tonight to September CocoaHeads. To start with, I'd like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and pay my respects to elders past, present, and emerging. I'll get started with a little bit of housekeeping tonight, and then we'll get straight into the first talk. So to begin with, hey, I'm Zach, and along with Christian, we run CocoaHeads together. So any questions, comments, or concerns throughout the night, come and speak to one of us. A reminder, as always, that CocoaHeads has a code of conduct. You can read it in full on the website, and the URL's up there. But it comes down to a few key points, and they are to be respectful, be inclusive, and be aware. This applies to sort of all CocoaHeads related things, including like the Slack group, as well as the meetup here tonight, of course. So just a reminder of that. Any issues or concerns related to that, please come and speak to Christian or myself, or send us a message after the fact. I don't think we have to sign in tonight. So thank you to our sponsor, Billu. We're here in their offices, and they help us out with all our ongoing expenses and cover costs to make nights like tonight possible. So we're very appreciative to Billu. And on the topic of sponsors, I did mention last month, I won't go into as much detail this month, but we are still trying to get a feel on if any other companies would be interested in helping us with our ongoing expenses as well. The main thing I think we're looking for is around potential venues, hosting, as well as sponsoring of the food and drink. We've got a couple of things in the works, but if your company might be interested or might be able to help out, please feel free to come and speak to Christian or myself, and we'll see if we can make something work. So I mentioned it before, we have a Slack community. I'll leave that up for a few seconds. You can scan the QR code if you're interested in joining, but it's a good place to hang out throughout the month with fellow iOS developers from all around Australia and New Zealand. And you can ask things like Swift questions in there, post about any jobs, or just a general chit chat about sort of Apple and iOS. I'll stay on that side for just a second longer. Cool. And a reminder that we're on YouTube tonight. So we have a live stream, as you can see Christian in the corner there, working hard to keep it up for the people at home. So don't forget to like and subscribe. Who's attending for the first time? Just a show of hands. Round of applause. Welcome, everyone. Hope you enjoy. Thanks for coming. If you like what we're doing here tonight, a reminder that Melbourne CocoaHeads runs once a month as well, and they have an excellent live stream, so it's very much possible to watch and enjoy from Sydney. They run on the second Thursday of the month, where we run on the third, so there's no overlap there. And speaking of events, this is a new one. We have an Aussie Vision OS Day coming up, and it's being run by Oliver, who you might remember. He's given some talks at CocoaHeads recently, and he was also on a Vision Pro panel, I think in February this year. So now he's organising a series of Vision OS days around Australia. The first one's definitely happening in Melbourne, so you can scan the QR code there to look at tickets and look at more details. And Oliver's posted lots of information on his LinkedIn page as well. But he's also looking to do one in Sydney. So this is more of a heads up in case anyone's interested, to stay tuned for the Sydney one. Of course, if there's more details before our next meetup, I'll mention it there. But otherwise, you can just keep an eye on Oliver's posts for that. Is anyone hiring or looking for work? More crowd tonight, so maybe no one. Okay, cool. If you are, or if something comes up during the month, feel free to post about it in Slack. There's still that jobs channel. All right, so looking ahead, we'll go ahead as usual on the 17th of October. That's next month. We'll post some details on Meetup, confirming the venue and things like that. But we are still looking for speakers. So at the moment, I don't think we have any lined up for October. So if anyone's interested in giving a talk in October, again, please speak to Christian or myself, or send us a message throughout the month, and we can work to make that happen. And importantly, this is the last boring slide that I have. Please remember to RSVP on Meetup, and importantly, remember to change your RSVP if you can't come. I'm probably talking to the wrong crowd since you're all here. But we have a huge disparity between the number of RSVPs we get on Meetup and the number of people who show up. It's okay to change your RSVP, but it does help us better sort of plan and organize the night. So if you suddenly can't come, please update it, and it really helps us. Okay, so that's enough with what I have to say. So we're going to get straight into our first talk by Dan on async flow coordinators. So I'll hand it over to Dan.
Okay, so my name is Dan Cutting, and my talk tonight is async flow coordinators. I'll get into what that means in a bit, but just want to tell you a bit about myself. Born in Newcastle, grew up in Sydney, lived most of my life though in London from about 2006 to 2020, 21. And have been doing iOS development since 2008 when the first SDK came out for a bunch of different companies in London, including Sky and Adavinta, and most recently for a company called Lightricks, who make Facetune, and the app I was working on was PhotoLeap. So async flow coordinators. Has anybody heard of the coordinator pattern for iOS? Yes, everybody, hopefully. Has anybody used it? Once? Okay.
Used it?
I think we all have. Yeah. It was very popular several years ago, and I've seen many implementations of it, many of which I don't agree with. I think a lot of implementations miss the point. But I wanted to talk about coordinators a little bit first, and then about our twist on it, which is to make them async. So when I talk about flows, this is the kind of thing I'm talking about, right? A sequence of views or screens and user interactions over time that make up some feature. So typically the kind of thing you might get from your designer if you're unlucky enough to work with a designer on an app. Right, you'll probably get Figma designs that look a lot like this, with loading states and branches for different interactions and so on. So that's what I mean by flows. Flows are inherently asynchronous, right? Because user interaction is inherently asynchronous. You don't know what you're going to get or when you're going to get it. So typically the coordinator pattern uses delegates and closures and so on to handle that asynchronicity. I'm suggesting that you can use async await instead of delegates and closures for your coordinators. So if you want a brief taste of that, I don't want to bury the lead too much, so I'll just give you a brief taste of what I mean. Something like this. You can have a function which defines your entire flow and uses async await to basically make a screen, push the screen, wait for user interactions, handle each user interaction, push another screen, go back, etc. You can do all this in a single function. But first, let's talk about flows a little bit more. So like I say, it's a sequence of screens or views with user interactions. It's the kind of thing your designer will give you. Every app has flows, right? Because every app has features, and you will have implemented flows somehow in your app. So the question is, how have you implemented them? Have you explicitly thought about defining them as a first-class entity? Or have you perhaps spread them across view controllers, right? All this flow code exists, but it's just where have you put it in the code base? Is there little pieces of it all over the code, or is it sort of a first-class entity somewhere? I think it's important to model them explicitly as a separate entity, like a class, for example. And the reason I think it's important is because flows are they're like a communication tool between all the stakeholders in an app. So the users think in terms of flows. They think of interacting with your user interface. The designers certainly think in terms of flows because that's exactly what they build in Figma. Product people, obviously working with designers a lot as well, so they're thinking in terms of flows like this as well. It's all boxes and arrows, and so I think if we can have the shortest distance from the concept of a flow that everyone has in their head to what we have in the code, then that's a good thing, because flows are probably the most malleable part, or should be the most malleable part of an app, right? These things change all the time. When a product person comes along and wants to add some new feature or change some feature, it's the flows that usually need to change. So being able to do that easily is important. Okay, so how do we model flows in iOS apps? How do we model these things in iOS apps? By the way, if at any point I'm not making any sense, please tell me. Please jump in. Any questions or thoughts? I'd love to hear it. Yeah, so I was wondering how I can talk about how we model flows. I thought I would just give sort of a timeline, the context of iOS history, I guess, and how various technologies and so on have come along throughout that time to change the way we model flows. So I went all the way back to 1979. This Smalltalk was a programming language from 1979. It's where the MVC pattern was originally talked about. And if you're wondering, yes, that does make me slightly older than MVC by a couple of years. 2007, we got the iPhone and Xcode 3 and Objective-C. This stuff all existed before 2007, but for iOS developers, this was like day zero. UIKit, the delegate pattern, the Apple MVC, which everyone has heard of, I'm sure. 2008 as well, the community started breaking away a little bit from Apple MVC and doing things like MVVM, MVP. I won't go into them too much, but I will talk about the delegate pattern and Apple MVC. This is the delegate pattern. And for the first 3 years of iOS development, this is how we had to write asynchronous code, right? You would define protocols with functions, and then you would set yourself as delegates. You would call some function which returns immediately, and then these delegate functions would get called back at some future point, hopefully, where you can carry on doing the work with the result of the asynchronous call. It looks nothing like synchronous code, right? It's all over the place. The code is jumping around all over the place. I'm sure this is nothing new for anyone, but especially when you started chaining asynchronous calls, it got really horrible, right? Apple MVC, let me show you an example of this. So, got a little app here which uses the Apple Flow approach. It's a bit big. There we go. Okay, this is a simple list detail app, the kind that you would, the kind that you would write if you were building an iOS app in 2008. Click on something and get a detail screen.
Sure.
Yeah. This is every app ever, right? And if you look at the sample code that Apple gave us way back when, you would see this kind of thing. You'd have, well, first of all, you'd have a storyboard. No, actually, first of all, you'd have nibs way back when. But I'll skip that brief period of horror for for now. Essentially, you've got these views here in your storyboard, and they can be connected with segues, which I'll talk about in a moment as well. But your separate screens, you'd have a list view controller here and a detail view controller here, and then a corresponding bit of code for that. And again, I'm sure this is nothing new, but I just want to highlight the differences as we go. So if you've got a table view and you select a row in that table view, then in the list view, we make the detail screen, we inject whatever data we need into the detail screen, and then we push the detail screen onto our parent's view controller, navigation controller, right, our parent container. And this, well, there's a few things to note here. So every step in the flow needs to know about the next step in the flow, first of all. Secondly, it needs to know how to create the next step in the flow. It needs to be able to build it and inject any dependencies it might have. And if you've got a long flow, then things near the beginning are going to need to know about things near the end so that they can get all those dependencies down there. Unless, of course, you use the singleton pattern or the service locator pattern, which is where these things came from in iOS. So there's three main problems with this. It's hard to reuse a view when it knows so much about its context, right? This list can't really be used in another flow because the other flow might want to do something different, maybe go to a different screen, right? And then you need to start putting in conditional code here. The view logic is also spread across lots of different places. So if we look back at this diagram, if you imagine that there's a sequence of views here, there could be a bit of flow code in the first one, a bit of flow code in the second one, a bit of flow code in the third one, and they're all part of the same feature flow, but they're spread across lots of places. There's no one place you can go and read the code. And finally, subflows are very hard to reuse as well. Just like the views are hard to reuse, if you've got some piece of this flow which is useful in other contexts, let's say like a login flow, because it's embedded in this other flow and it's got all the context of it, it's hard to use that login flow from somewhere else, again, without putting in lots of conditional code. So this is the problem with Apple MVC. Okay, so back to this. In 2010, we got blocks in C, which was great. And later on in Swift, of course, we have closures, which are the same thing, essentially. This is the second major way that we had to write asynchronous code on iOS, and it is much better than delegates for some things. It's still not good enough for many things. But the idea is that you can now inline your the code that handles the result of the asynchronous call can now be inlined with the call itself, which is a huge improvement. Some of the problems with it, though, you end up with pyramid of doom, if you've heard of this, which is, you end up with like constantly indenting to do one asynchronous call after another. Not so nice. But worse than that, you still can't use the nice flow control mechanisms that Swift gives you in this way, because we're contorting the code. We're not writing normal synchronous Swift code where you've got things like throws and defer and return even, right? You can't do any of that stuff. You've got to contort the code into this strange, okay, now I'm writing asynchronous code. And you lose a lot of the nice flow control mechanisms of Swift. Okay, 2011, Xcode 4. It took 4 years to get a new version of Xcode, or 3 years, from Xcode 3 to Xcode 4. But it gave us storyboards and segues. And this was notable because it was the first time really in iOS that we had this way of explicitly describing a flow. right? You could look at a storyboard and you could see the flow as it was intended by the designer. Perhaps this looks a lot like a Figma design, so there's this nice parody. In reality, segues are awful. Please don't use them ever. Yeah, they're a nice idea, but they don't address the fundamental problem that the flow is still spread across all the views, right? And now it makes it worse because the segue gets out of sync with the code, and when that happens, you get crashes, right? So segues were a dead end, unfortunately. I'll just bash through these quickly. 2012, clean architecture. There's a blog post about that from Uncle Bob. If you've not read his book, Clean Architecture, I highly recommend it. It's not a prescriptive architecture as such, like MVVM or something. It's more a set of principles that are really good for just factoring your code. Strongly recommend reading that. 2013, we got FRP and reactive Cocoa, and later RX Swift and things like this. What can I say that's nice about FRP? It's a really beautiful idea, taken way too far. Yeah, it's mathematically pretty, right? It's seductive, I think, is the problem with it, actually. It seems like a great idea. And it is good for some things. It's good for keeping your views in sync with your view models and that sort of area of the code base. It's not good for building the entire rest of the code base. And it's particularly poor for explicitly modeling flows in the way that I'm talking about. Right. Swift 2014. Yay. That's a good year. Yeah. Sorry? Viper not so good, yeah. Viper is like clean architecture in a straitjacket, I think. That's how I would describe it. 2015, Redux. Another beautiful idea taken way too far. It's essentially an evolution of Flux, but yeah, like I say, taken way too far. It has the same problem that your flow code is spread across lots of different small places because everything goes through reducers, and the flow for any particular feature is spread across multiple reducers. So it doesn't help us try to explicitly model our flows. But 2015 was also the year we got the coordinator. And there were two devs around 2015 and 2016, Suresh Kanlu and Krzysztof Zabolotsky. And I think they did some talks, but they also wrote some blog posts. And they're very short and very well written and very easy to understand. And if you haven't read them, please read them. They're really good. There's the coordinator, that was the first one. There was a follow-up one from Suresh a few months later. And then Krzysztof's flow controllers blog post here. But they're both essentially the same idea. So what is that idea? I'll just quickly show you. Okay, so maybe I can do this. No, that's not going to work. No matter. The basic idea of the coordinator pattern is to take the little bits of flow code that are scattered across the different views and gather them all up and put them into a separate object called the coordinator. So if we look at our Apple Flow example again, when you select a row, we make the detail screen, we inject it, and we push it. In this simple example, that's pretty much all the flow code there is. So what we can do is create a flow object. We'll call it the star browser flow. And we'll just take that code as is, move it into this class here. So now we have that code here, right? Completely unchanged. And the only thing we do is then use the delegate pattern to allow the view to tell the flow that something has happened. So the view now doesn't know how to make the next step. doesn't even know about the next step, doesn't know about the nav controller. All it knows is that something has happened and it needs to tell someone. So we use the delegate pattern here. The view has a delegate that it can call, and when something happens, it calls it. This view is now what is called a humble view, meaning it doesn't have any opinions, really. It just it gets given some data which it will display, and it tells someone else when something interesting happens and lets someone else decide what to do. I think it was Martin Fowler who came up with the humble view term, which I think is a good way of thinking of it. If you're ever not sure if a view should do something, just ask if it's humble. And then if we go back to the flow here, we make the list screen, we set ourselves as the delegate, and we push it. And because we're now the delegate, when anything happens, this delegate function will get called, and the next step will happen. So that's the coordinator pattern. It's as simple as that. You don't need to do anything else. You don't need subcoordinators, arrays, or any of the other stuff that people have added to it. You just need this idea that the flow code moves out of the views and into a single object somewhere else, which orchestrates those views. So this is really nice because it solves the three problems. Like I say, we can now reuse that list view because it's a humble view. We can now look in one place to read the code for a particular flow. It's all here. And we can even make subflows and reuse those as well, because now we have this idea of a flow. We can make flows call other flows. Right? They don't just have to orchestrate views, they can also orchestrate other flows. And this means it's a really powerful concept, essentially, for reuse. But the problem here still is because we're using the delegate pattern, it's not quite as clear as it could be. It's not too bad in this case because we only have one callback, but in flows that get bigger, longer, more views, more callbacks, etc., the delegate pattern starts to show its faults. In this case, we have a little bit of flow code here and a little bit of flow code here. But there's no explicit link between these two pieces of flow code, right? You can't look anywhere in this file and see the connection. You have to sort of know that the view will call this function at some point. So it's good, but it still could be better. Okay, and then Swift UI was 2019. We also got this result thing, which is it's basically a hacky workaround for completion blocks not being able to throw errors like we might like in normal sequential Swift code. If I just quickly go back to the block version, you can see that a completion block here has an optional thing and an optional error because we don't know if it's going to succeed or fail. This is how it was usually modeled. The problem with that is there's 4 different states then that this could be in, right, even though only 2 of them are valid. So you have to deal with all the whatever. The result type was a way to deal with that. So it's good, like it helps. It gets rid of those 2 states, but it doesn't help too much really with making async code any better. But in 2021, with Swift 5.5, we got async await, and this changes everything because the asynchronous code we write now can have the same shape as the synchronous code that we write. And this has many benefits. So first of all, I'd say it's more readable. You can just read it in a straight line. There's no pyramids of doom, anything like this. But probably even more important is that you get all of the flow control mechanisms of Swift. You can just use them on asynchronous code now. And I'm talking about things like throwing errors or deferring statements or just returning a value, right? It's just the same as writing synchronous code now. You have to scatter await and async everywhere, of course. But apart from that, it's pretty good. Okay, so that's the timeline from iPhone to now, roughly now. In 2021, I was working on a large app, a big old code base, about 10 years old, which had a lot of different architectures in it, a lot of different technologies, Objective-C++ everywhere for some reason, lots of FRP as well. It was really interesting and fun, but it was a dog's breakfast, yeah. I like to clean code, so it was fun for me. Yeah, we started moving towards the coordinator pattern. We were trying to break out some common flows, like we had a login flow and a subscription flow and export and import flows and things like this, which we needed in lots of new features we were building. So we started using the coordinator pattern for it with the delegate style. And then in 2021, async await came along, and we realized that async await is just a nicer way of writing delegate code. So we basically applied it to the coordinator pattern, and that's what the rest of my talk will be about. So let me show you well, I will just say we had a couple of teams with about 12 devs over 2 teams working on this, and we spent about 3 years writing this style of code. Dozens and dozens of flows, a lot of features basically, and in general it worked really well. There were some gotchas, which I will talk about later. It doesn't solve everything, and it introduces some other things which are a bit weird. But on the whole, I think this is a really nice way of writing a feature. So let me show you the most basic example I can. So again, building on this this same list detail example. This is the delegate style flow. We set ourselves as a delegate and we wait for the callback. We've got these 2 sections of flow code. With async flow coordinators, you can merge all of the flow code into one function, like this. So there are those 3 initial bits. There are those 3 secondary bits. And you may have noticed that the start function is now the run function, because it doesn't start the flow, it runs the entire flow, right? The entire flow is in one function. So we make a list screen, we push it, and once we've pushed it, we just need to loop over user interactions, right? We just want to handle each one as it comes along, do something with it. In this case, there's only one interaction, which is tapping on a row. And when we do that, we make the screen, inject whatever, push it, and then when the user comes back, we just loop over it for the next interaction, so they can go to the next star. So I'm glossing over a fair bit here. You may be wondering, like, how do you go back, or what is this thing? Maybe I'll address this one first. So this is the event stream. It's really just a very small class which we wrote to convert imperative calls into an async stream. There's no magic to it. It's very straightforward. I can show you the whole, where is it? Show you the whole thing there. There's some weird words in there, I agree, continuations and async stream. But if you're familiar with async await at all, then the concept of an async stream is just a stream of elements that can appear over time and can be serviced over time. So all we do is create an async stream, and when we do that, we get this thing called a continuation, which we hold on to. And we need the continuation because that's how we yield new things into the stream. So when someone calls add on our event stream, we just yield it into the async stream. And so in this way, we can convert a normal function call into a stream of T, whatever T is. It's just some sort of user interaction. So just to make this example a little clearer, we create this stream, and we're looping over the things that are in that stream, and the things get into that stream through this. So let me show you the view. If we look back at the old list view controller, we had the delegate pattern, if you recall. And when the user tapped a row, it just called the delegate did tap star with whatever star. Now all we need to do is replace the delegate protocol. So it's even the same number of lines of code, apparently. We just replace the delegate call with an enum of the kinds of interactions that can occur. So just like the delegate protocol. And instead of having a delegate, we just have a closure, which the view can call to pass an interaction. And it does that here, just like calling the delegate. It's really quite similar. We're just using a closure instead of a delegate, basically. And the flow can then just hook that up to that add function that I showed you earlier. So anytime the user taps on a row here, it calls the did interact closure with an interaction. That interaction then gets fed into the list interactions stream through this add function, which is this thing that yields the element. Don't worry if that doesn't make too much sense. It's something you don't think about when you're writing this stuff normally. It's just, you just have to hook it up like you would a delegate, basically. But it means that we can now use this for loop to just loop over these interactions as they occur. Okay, so that's the simplest example. I want to show you a bigger example. Let me run it first. So it's the same basic structure. We have a list and a detail, but you'll notice when it started there was a loading period. It was going away and loading the stars from a service. The user can now refresh as well and click through as before, and when you click through it's also going to a service and loading the details. There's also an action here that the user can do to share the picture. So how do we go from what we have in this flow so this is the previous flow without any loading, and then to go to the new one we just need to add some new stuff to that run function. Basically we want to change the flow, so we change the run function that defines that flow. We still make the list screen and push it just like we did before. There's some other things which are a little different, like we're returning the list interactions from the screen builder rather than building it inline, but there's no difference there. We're just hooking it up in this function. I'll come back to this on pop thing in a bit. But basically the first two lines there are just doing exactly what we did before. We make some interactions, we make the screen, we push the screen. Then, because a flow is a sequence of events, the next thing we want to do is refresh the stars. We want to load the stars. So we just wait for that to happen. And what that means is that we, in our list screen, we'll set our mode to be loading, which means it will show a spinner. And then we just wait for the repository to go and fetch the stars from some service. And once it's got it, we just set those stars on our screen. Right? So very sequential. When that's finished, then we're just waiting for events, interactions on the list screen, just like we did before. Something to note is now there are two different interactions a user can do. They could tap on a row or they could tap on the refresh button. So when they tap refresh, we just refresh the stars again. And we just await that. And when that's finished, then we grab the next interaction from this stream. And if they tap the star, then we run the details screen. And you can think of this actually as like a little subflow. We wait for the detail screen to run, which means we, well, I can show you the function. We make the detail screen, we push it, we set it to loading as well. We go and fetch the star from our service and then display the actual result. Then we wait for some interactions on the detail screen, right? So the user can tap the action button. And when they do that, then we make an action sheet and present that. When this function ends and returns, that means the detail screen is done. And that means that the detail screen has been popped because it's no longer on the screen, it's no longer needed. And when that happens, this line will continue, and then it will grab the next interaction from the list stream. So you can see how the structure that you have in a navigation controller, it's essentially a stack, right? We are just mirroring that stack in the call stack here, right? We're running the list, and then we run the detail, and when the detail finishes, then we keep going with the list. It's just like a call stack. And it's actually worth noting that you can think of the entire app behavior as being a single function, which you call run. And that will call some other run, and that will call some other run. It will do some looping. It will come back. It's just essentially one gigantic call stack for the entire app. When it gets right back to the top, then the app is done. Of course, that doesn't happen in iOS, but you know, in most iOS apps, you'll just be sitting in one of these for loops forever until the app is killed. Okay. Is this making any sense? Yes? Any questions yet?
Why didn't you give this talk last month?
Sorry?
Why didn't you give this talk last month? Removing coordinators.
You're removing them. Okay. I'm sure you have a good reason.
Okay. Where was that run handler first called? I don't see where that.
Oh yes, great question. I haven't talked about that. Yeah, so this is the star browser flow. This is the run function. It's the entry point to the flow. You call that from your scene delegate. It's the root flow in the app.
It'll be all chaos if you call it twice.
Yep. Yep. Actually, there's a lot to talk about in terms of because it's async await and it's essentially blocking, right? Things block on async await until they return. So you can get into states where the app appears to hang if the view gets out of sync with the flow state, right? And I'll talk about that right at the end. That was one of the gotchas I mentioned. But yeah, here this is in our scene delegate. We just create the flow and hook it up to the window, and then call run there. And that starts the whole thing in motion. Okay. So I've got one more complicated example, which touches on some of the nice things that this lets you do. So let me run that for you. This is the diagram I showed you right at the beginning. Got a loading screen, you've got a login screen. Cancel that, you go into the project screen. You can see that we're not currently logged in because I didn't log in, but I can tap that, show the login screen again, log in, and now I'm logged in. Tap that again, it'll ask me if I want to log out. I can do that. And now I'm logged out. So this is exactly the flow I showed you here. So the question is, can we model this flow explicitly using async flow coordinators in a way that makes any sense? So far, the examples I've been showing you have been using UIKit for navigation controllers. You don't have to do that. In the app that we were working on, we decided to use UI navigation controller for most of the actual screen navigation. And then we use Swift UI for the views that were in those screens because navigation in Swift UI is kind of terrible, or has been for a while. I think it's getting better. But that works fine. But if you don't want to use UIKit at all, it's possible to do all this with Swift UI as well, like pure Swift UI. So that's what this example is. It is a little more complex, so just bear with me. If you've got any questions, just please shout out. So again, this is the entry point for the app, and we create the main flow and run it. We hook the flow up to a main flow view so that we're hooked into the SwiftUI view system, basically. And then the main flow is just this. Here's our run function. First thing we do is show the splash screen. Second thing we're doing is loading some projects. Then we run that login flow that we saw. And this is an interesting thing to note. We're waiting for the login flow to run, and when it comes back, it'll actually return us a useful value. It's not just running and returning, it's returning the logged in user. So if the user logged in, we'll get a user object back. If they didn't, we'll get a nil back. Then we run the project flow, and we set the screen to show the project flow. So that's the entire app. And if you want to see where it goes, you can just follow the run commands down, basically. So if we look at the login flow, say, we just follow the run. And this is how the how the login flow works. So it's a run function, it's asynchronous, it returns an optional user. All this one does is listen for some interactions from the user. They may tap the login button, they may tap the cancel button. If they tap the cancel button, then they're not logged in. We just return a nil user. If they tap login, we show the loading spinner, and then we try and hit some service to authenticate the user. And this is obviously needs to await as well, so it's hitting some web service. And when it returns a user, we just return it right here from the middle of the flow. Because we're using async await, we can now use all the nice Swift flow control mechanisms that we get. So we are deferring, for example. In this case, we make sure that the isLoadingUser spinner is always set back to false after this call. Defer is one of my favorite keywords. I think it's underused. It's very cool. It's really good here for putting the two calls together, but making sure this one happens right at the end. We're also using try. Okay, so the user loader may fail. Maybe the user didn't authenticate properly. Maybe there's a network error. We'll throw an error, and then we'll catch it, and we'll reset. And when we reset, we're just setting the username and password back to empty, and then going around again for the user to tap cancel or tap login. So that's login. Going back to the main flow, there's also this project flow. Let's go have a look at that. Again, just some interactions here to handle. If they tap on that account icon, if the user is not currently logged in, then we just run the login flow, and we get a user. Or not, we may not get a user. If the user is currently logged in, then we want to show the logout alert. That was that alert that we got. And I'll show you where that actually hooks up in a moment. If the user then taps the logout button on that alert, we just set the logged in user to nil. So this raises a little question of how do we show the alert, for example, here. We're just setting something to true. This is the way you do things in SwiftUI. You have properties so this is an observable object, and you have properties on that. In the past, you would call this a published property. Nowadays, it's observable. But then we have our project flow view, which observes those things and shows the alert when it's true. So I want to talk about these flow views quickly. I'll show you the first one, actually. So each flow, if you're using SwiftUI, you need to do this. You need some sort of bridge between SwiftUI and this imperative flow code, because you've got imperative flow code and declarative views. You need something to marry the two. So what we did here was to make a bridge, which we call a flow view, and it just observes the flow. And in this case, remember there is a screen property. We can either be on the splash screen or the project screen. And it just switches based on that. If we're on the splash screen, show a splash view. If we're on a project screen, show the project flow view. And we've also got this sheet here, which is how we display the login flow. So the code here is very simple, intentionally so. There's no actual logic here. This is just for hooking up the things that are happening in the flow to SwiftUI views. The actual leaf views, like the splash view, for example, just a dumb view, just another humble view. In fact, all of the views are humble views. The project view is just a list of projects. The account indicator view, that button in the corner, it's just a name and a closure when you tap it. So I think that covers most of it. That shows all the benefits of using async await. You can use all the flow control mechanisms. You can easily do things like subflows, which return actual useful results. Yeah, I think that's it from the stuff I want to demo, and I can talk about some of the problems in a bit. But are there any questions at that point?
Does it make sense? Does it look ridiculous?
Yeah, it's I think once you get used to being able to just call a flow and have it go off and do it and get some result back, it's really useful. We use it if you have an app that actually needs to remix things in lots of different ways, as we did on our large app. This kind of stuff was a godsend. We could reuse things all over the place. We could reuse all the views. We could reuse all the flows. It was really good. Just a disclaimer: I have not used this pattern with SwiftUI as I've just demonstrated. This is a toy example. I have not tried it in a real production system. So, there be dragons. But certainly in terms of using UIKit for navigation and SwiftUI views for leaves and all of the async await stuff I've talked about, it can work really well. Okay, so some of the downsides. This is, first of all, it's a downside that is true of any sort of application of the coordinator pattern, which is that UIKit and SwiftUI sometimes do things that the user asks without letting our code be involved, right? So what I mean is if you're in a navigation controller and you swipe back or you hit the back button, there's no way to intercept that or stop it or anything else. You can hide the button, you can disable the gesture, you can make your app worse in this way if you want to do that. But there's no way to actually, well, there's no easy way to really deal with it. So this has been a known problem of the coordinator pattern for many years, and there's been ways to solve it. There is actually one little trick you can use to detect when a back gesture happens, for example. And I did briefly show it actually in one of the things here. Where was it? Yeah, the on pop. So I've got this thing here called a navigator. It's really just a navigation controller, but it's wrapping a navigation controller with just a little bit of extra code that digs into the guts of the transition coordinator to see when these back things are happening. And it lets you attach some closure to be called when whatever view controller you're pushing now, whenever it gets popped, it can call this thing. And this is useful because it means you can break out of this for loop. So the user has said, go back. We don't want to go back because that's not our flow. Our flow is just looping on their interactions. But UIKit is letting them do it anyway. So we have to hear about it. And when we do, we can just kill this, this for await loop. And that means that this function will then return. So that's a way to break out of that situation. If you don't do that, you end up with what I called before dangling flows, which is when the state of the view and the state of the flow are out of sync. And that is because the flow is supposed to be the one that's in control of what's going on. But if the user does something and UIKit lets them and doesn't tell us, then they can obviously get out of sync. And that will essentially hang the app, or it'll feel broken because the user won't be able to do anything anymore. because we're still waiting for interactions on a detail screen, which is no longer on the screen. Right? So be aware of that. But once you know about that, it's quite easy to work around. There's a similar problem with Swift UI. You can, where is it? So sheets, for example, you can swipe down to dismiss a sheet, and it's a little bit nicer in Swift UI because we are at least able to give it a binding, and the binding will be set to nil when this happens, and so we can observe that and kill that login flow. So this is one of the warts of this approach, but this is a general coordinator problem. Deep links. Yeah. Deep links are hard anyway, no matter how you've designed your app. But it's a bit tricky here because essentially, if your flow is somewhere deep inside a flow, your app is somewhere deep inside a flow, and a deep link comes in, what do? You need to somehow, well, I mean, you can make a decision on terms of the product and what you want to do. Do you want to abort the current flow? Do you want to show the deep link in a modal or something? I don't know. If you do want to abort the flow, there's not a really easy way to do that because, like I say, async await just blocks for things. So if you want to abort a flow that's, several items down the call stack, it's not trivial. We didn't find a great solution for that, to be honest. We tried a few things, and you can make it work if you do modals and whatever, but that is something to be aware of. If deep links are very important, then you'll need to think about how that will work. And the last gotcha is acceptance testing. So if you're writing this kind of coordinator, a delegate-based coordinator, sorry, not this one, this one, the fact that it's actually broken into little pieces is a feature in some ways because it makes it easier to test. This line here becomes a seam that you can test against, right? I like to write acceptance tests which test flows, and writing acceptance tests for coordinator delegator patterns is very easy because you can just start the flow and then you can just say, okay, I've tapped a star, and you can see what happens. With async await, it's not easy. In fact, I'm not sure how to do it. We tried a few different things here. You can inject an interactions thing, which you can push events into to get it to the state you want or something like that. But because it's all happening in the one function, and it's just blocking on these streams, there are far fewer seams for you to work with for your testing. So if acceptance testing of your flows is very important, then delegate might work better. Sorry, say again. Mm-hmm. Well, it's more. The problem is how do you actually poke the flow into the state you want, right? Because if you're using the delegate pattern, then you can have a stub view or a fake view. Well, you don't even need a view. You can just directly call what the view would call on your flow and have it move through whatever states you need it to get to do your tests. But in an async await flow, the only way to get it to move through states is to put things into this interactions stream. And because it's created here, you can't do that. Yeah, so you have to inject it, and then you have to put things in it or something. Kind of ruins the nice lines that you get of writing it this way. So yeah, it's something to be aware of as well. And I think that's it. These are the links for the coordinator pattern. Back to 2015. If you haven't read them, please read them. My name's Dan. You can see me on Mastodon, and I've also got a blog, which I post to almost never, but I'm trying to post more often. Thank you. Yeah, sure. If anyone has any questions.
I can kick us off. So you know how kind of every interaction you need to wait for whatever's running to finish before the next one starts. Is that a problem in a real app? I know it's probably not a problem in the code we've seen tonight. And if so, how do you handle that?
So I think you mean, for example, here, for example. So yeah.
Yeah, like if you have multiple stacked up, you have to wait for refresh stars and whatever to finish before you could possibly run it. I mean, I know in this case it doesn't matter, but yeah.
No, it's a good point. And it comes down to the feature you're building, really. Usually the interactions that you're dealing with kick off something, and you want that thing to finish before you do the next thing. But sometimes you want to kick off some background process or something like that. And because we're using async await, we can do that. We could we can create a new task, say, which does something, and we could keep a reference to that. And then later on, we could have a cancel button, which is able to cancel that task or other things, right? It totally depends on the feature that you're building. But I will point out as well that you do have all the power of structured concurrency in these kind of flows. So for example, here, I'm using async let. So these projects are loading while these other things are happening. The projects are loading while the login flow is running. So you can use structured concurrency in that way to
kind of imagine the situation, but like, yeah, and how would you solve it?
Yeah, it's not good. Like when your entire interface just stops working. Yeah, because this for await loop becomes a really critical piece of every flow. If it doesn't exit, then the flow doesn't exit, right? You have to really start thinking in terms of call stacks and things exiting, and they need to exit at the right time. The main reason we got these dangling flows is, like I say, it's when the user does something that UIKit is happy to do without telling us. Because the idea of the coordinator pattern is that it's in control and it's orchestrating all the views. But if UIKit just does something, then that turns that on its head, right?
So like you might be waiting for something.
Yeah, the classic example is if you're in like a list detail navigation controller, you go to the detail screen, we're waiting here in this for loop for these detail interactions, and then the user swipes back, and we're still waiting for a detail interaction, and it just never comes because there's no view anymore, which is why we need this thing. Actually, I can demonstrate that, I think. So I'm going to do some live coding, so God help me. So if you go into here and then you drag back, this will work because we capture that event and finish the for await loop, and similarly with the back button here. If I don't do that, so basically if I just never call finish on the detail interactions when this thing pops, then we should get a hang, which means that you'll go back to the list, but you won't be able to do anything on the list.
Still waiting for the detail to finish.
Yep. So you've got to remember that the call stack has to map to the views, basically. And like I say, the only time it happens is when UIKit and SwiftUI do these things on the user's behalf. And there's only two cases that I know of that do that, which is the swipe to dismiss and the swipe back.
Wouldn't this generally be actually easier with SwiftUI? Like, where, I mean, it will still do that, but like most of the time you still kind of have hooks just because of how SwiftUI is all like sort of state-centered and like state-based. Like, it almost feels like in SwiftUI you would probably have like easier ways to sort of like naturally hook into like those situations when it's SwiftUI doing something for you to sort of like wire your code that will sort of stop those loops.
Yes.
So you said you're using SwiftUI for the view itself, the UI kit for navigation. So
Yeah. Yeah.
if pure SwiftUI all the way through, if it can work.
They are. They're quite different. So to answer your question, or your point first, yes, you're right. SwiftUI does make it easier than UIKit. UIKit really doesn't want you to do this. they really bury it. But the last example I showed, this one, this is all SwiftUI. There's no UIKit here. And when you run the login flow, we do that by setting a login flow property. And then after we're finished, we set it back to nil. And this is an observable property on this main flow. And our bridge class here is using the binding to that. So when the login flow appears, then the sheet appears. And if we explicitly nil the login flow like we do there, then that will hide the sheet. But if the user manually hides the sheet, then this will also set it to nil. So this will be set to nil, and at that point we can hook in there and break that for or wait loop that the login flow is doing, because the login flow it's in here, right? If we didn't do that, then it would just continually be waiting for another interaction. It's why we have this strange little return nil at the end here, because this loop can actually exit, and we have to return something. So we just return a nil user. And sorry, what was your?
Just about the fact that some of this comes about because it's a hybrid of UIKit and SwiftUI. The UIKit navigation, but SwiftUI. But that might be different. It was all SwiftUI, including navigation.
Yes.
Don't know.
Yeah. SwiftUI, totally SwiftUI is quite different to using UIKit for navigation. You can see here the code is kind of different, right? We're setting properties to manage the transitions, whereas in the UIKit world, we're pushing things onto navigators and so on. So it's quite a different way of working, but the principles are the same, right? You can still use async await for both of them. I can just quickly show you the navigator, how that works. It's just a navigation controller. It's just wrapping that, and this is the code that you need to write to detect when the user has done a back gesture. You have to look in this thing. It's awful. Yeah. No, this has been pretty much the same since Sarush first put out the coordinator pattern. Like immediately people started realizing that the back gestures broke everything. So this was the solution that was found. Yeah, you don't have to change this. Once you've got it, it just works. Any other questions?
Excellent.
Cool. Thanks, Dan. That's all right. That's good. All right. Well, thanks everyone for coming tonight. We don't have another talk. Feel free to stick around for a few minutes if you want to have a chat. I think there's a bit more pizza left, so feel free to grab a slice on your way out. Otherwise, see you next month, and thanks for coming.
Thank you.